At Joe Gibbs Racing, every day is race day. Starting Monday morning, the team works against the clock to fix technical issues on each race car. The deadline, Wednesday afternoon, when the cars are shipped to next Sunday's races. The problem is, designing and machining new parts for a car can take, on average, 33 days or more, using traditional methods. But at Joe Gibbs, they get it done in 3 days, using a Fortis 3D production system.
Our tires were getting too hot, we were blowing them at the track, so that led to performance issues. What we needed to do here was channel some air between the rotor and the tire and push some of that hot air out that the braking was causing.
With his CAD software, engineer Scott Temple designed a more effective cooling duct that fit just above the brake rotor. To quickly test his design, Scott loaded the CAD data into the Joe Gibbs Fortis 3D production system, which built an accurate concept model of the new duct.
I mean, you basically load your program into the computer, you hit go, 4 hours later we have this part, you take it right out of the machine, no problem, rip it out, you got a part right out of the machine, as easy as that.
Some of the prototyping we used to do in the past we would do in the CNC shop, and we would do that on a mill or on a lathe. Some of those pieces would take a complete set of fixtures and tooling, and those prototypes would take approximately a week. Where today we can do some of the conceptual prototyping in around a day, and we can do that with the Fortis system.
After working through more iterations Monday afternoon, Scott sent a design to the Fortis system for an overnight build of a functional prototype.
From here we were able to make the part in the Fortis system, bring it over to the car. You can put it right up to the part you're going to mate it against and see that you're not going to clear the caliper. So we're able to take it up to the computer, change the model a little bit, put it back in the Fortis system. 10 hours later we had another part put right back on the car and see that it was going to work.
Scott corrected the clearance problem and produced a second prototype on the Fortis system late Tuesday morning. The new design fit perfectly, but the team still had to build the actual air duct out of graphite composite fiber. For this, they used the Fortis system to accelerate the manufacturing process.
And once we had a revision that we were happy with, we created a solid of the part in the Fortis system that we could then pull a composite mold from, like that. Two-piece mold that had that was fenced, so we could pull it apart. And then out of these pieces, we developed an actual composite carbon fiber part that could be used to do further track testing and get onto the race car.
On Wednesday morning, the graphite composite fiber was laid up. The final part cured in a vacuum bag in an oven until early afternoon.
If we use a low enough temperature resin, we can actually use FDM materials as our molds because they'll stand up to the temperature as well.
By late Wednesday afternoon, the finished air duct was bolted on the race car, which was quickly loaded into its hauler and transported to the next race.
If we have a problem on a Sunday during the race, we'll be able to get some data analyzed sometime Monday morning, and we have to generally have a plan by Monday afternoon with pieces and parts to go to the racetrack, on Wednesday. So in general, it's about a 2.5 day process. In a lot of cases, it would be very difficult to meet that challenge without a dedicated FDM machine in that.